In this section, we'll talk about spacing, density, and excess. We'll learn how these things are measured, and we'll understand why targets are set in silviculture prescriptions. We'll talk about compliance systems, and how, as a planter, you can leverage an understanding of these systems into increased productivity and higher earnings. If you have a proper understanding of what you can and can't get away with respect to spacing and density, your job will become a lot easier.
When a forester takes a plot, he or she is not checking the quality of the trees. There's a lot of additional information gathered. In rough terms, the information collected in each plot includes the number of trees planted in the plot, the number of plantable spots, the number of excess trees, the number of satisfactorily planted trees, the number of unsatisfactorily planted trees and reasons why they were unsatisfactory. This is the quality assessment part of the plot, and any other comments about the plot in general. As you can see, most of these measurements are not even directly concerned with quality.
Density is a very important measurement that tells you the approximate number of trees per area on a block or on part of a block. Since we usually use the metric system, it's usually described as the number of seedlings or stems per hectare. A hectare is 100 meters by 100 meters in size, or 10,000 square meters. And of course, it doesn't have to be a square. Earlier, I mentioned the fact that a plot within the 704 system is equal to 1/200th of a hectare. Because of this, if you know that you have a number of plots that average 8 trees each, and a plot is 1/200th of a hectare, then when you multiply the two numbers out, you'll realize that you have approximately 1,600 trees per hectare. This density, which is determined by multiplying the average number of trees per plot by 200, is usually called the plotted density. Sometimes it's called the plot density, or sample density, or statistical density of the block. There's another way to arrive at a slightly different density calculation. You can take the total number of trees that were actually planted on a block and divide it by the number of hectares. For instance, if you have a block on which you've planted 15,000 trees, and the size of the block is 10 hectares, then you have a density of 1,500 trees per hectare. This density, calculated from the claimed planting totals, is usually called the planted density. It may also be referred to as the claimed density or theoretical density. It's important to understand right now that there is a significant distinction between the plotted density, which is a statistical measurement, and the planted density, which is the true density, if the planting totals are correct. Although each density is a measure of the number of trees per area on the block, and although each may be accurate by itself, the two types of density measure slightly different items. It's possible for the plotted density to be different than the planted density, and yet for each number to be correct. A correct plotted density merely refers to a plotted density that is calculated correctly. It does not mean that the plotted density accurately reflects the exact true planted density of the seedlings on the block, because it's a sample. If you truly understand the distinction between plotted and planted densities, that distinction will form the basis for starting to understand a lot of other nuances of most quality systems. Understanding this distinction also helps you to start to learn some of the advanced density management issues, including issues as varied as manipulating the system to improve your quality results as a planter, and, for management, investigating the likelihood that planters are stashing trees. Some planters, especially beginning planters, will focus entirely on their planting quality and pay very little attention to the planting densities that they achieve. This is possibly one of the biggest mistakes that a beginning planter can make. I simply can't overemphasize the importance that density will play in your planting career. Look at it this way. Making a quality mistake is not irrevocable. Planting a tree poorly, so it's considered to be a fault tree, will unquestionably reduce its chances for long-term survival. Even if it does survive, your poor efforts will probably reduce the eventual yield from the tree because it may not achieve its maximum potential growth. But despite this, a tree can recover from many types of quality faults. A quality fault simply means that the odds are stacked a bit higher against the tree. A tree in a dry area may not grow well until it gets heavy rains. A tree in a poor microsite may not grow as fast as one in a better microsite. A tree with non-vertical, or J roots, may not establish a strong root system as quickly as it could have. A leaning tree may take some time to straighten up. But despite all this, a tree can often recover from a quality fault. With density problems, the story is different. Once a tree is planted in a particular microsite, it can never move. Quality faults, if they don't kill the tree, may only be temporary setbacks in the total life of the tree. But trees can't move by themselves, so density problems are permanent. The vast majority of foresters are very intelligent, and any forester with any common sense recognizes the importance of density and will be far more tolerant of a few minor quality issues than they will be of density issues. Another thing to consider is that most common quality systems are designed so that when a planter's density starts to get really out of line, it also starts to have a negative effect on your quality percentage. For example, under the FS704 system, planting low density will eventually result in missed spots, which is an automatic quality fault. Under the same system, planting high density will usually result in an excess fine, which again is not good. Okay, now that you understand the basics of density, I'm going to explain two new issues: target spacing and minimum spacing. Sometimes target spacing is called the contract spacing. On any given contract, a forester will have come up with an assessment of how many trees they want planted in an area. If the area is rich and non-competitive, and the trees are expected to do well, a low density of 1,200 stems per hectare may be a good goal. In areas with poor soil or high competition from existing vegetation, a higher density of 2,400 stems per hectare might be a better goal. On some contracts, the density that the forester wants to see may not be a single number for the entire contract, but may vary from block to block, or may even vary from section to section within a block. No matter what the desired density is, it's very difficult for a forester to get good results by telling a planter to go out and plant about 2,000 trees per hectare. This instruction is too vague unless you understand how to apply that number to the immediate area that you're currently planting in. Even after all the years that I've spent planting, I can't tell you exactly how big a hectare is at a glance, nor could I do a very good job of just guessing how far apart the individual trees need to be in order to fit exactly 2,000 trees into a hectare. I need a more tangible and achievable measure to aim for. Depending on the target density, it's fairly easy to use a chart to determine what the average inter-tree spacing needs to be to achieve the desired density. Once you have a tangible inter-tree distance to aim for, you have a realistic chance of meeting the forester's goals for density. For example, if every tree were 2.4 meters away from every other tree in a perfect grid, the resulting density would be 2,000 stems per hectare. If every tree were 2.7 meters away apart in a perfect grid, the resulting density would be 1,600 stems per hectare. Your foreman can tell you the average spacing that will result in the target density that the forester is looking for. Foremen and supervisors have charts to help us know what our target spacing needs to be. Let me show you several common numbers right now. For 2,000 stems per hectare, which is 10 trees per plot, you need 2.4 meters on average between trees. 1,800 stems per hectare is 9 trees per plot, so you need 2.5 meter average spacing. 1,600 stems per hectare is 8 trees per plot, so you need 2.7 meter average spacing. 1,400 stems per hectare is 7 trees per plot, and you need 2.9 meter average spacing. 1,200 stems per hectare, 6 trees per plot, 3.1 meter average spacing. 1,000 stems per hectare, 5 trees per plot, 3.4 meters average spacing. And finally, 800 stems per hectare, 4 trees per plot, is 3.8 meters average spacing between trees. For a first-year planter in the northern BC interior, you're probably not going to see low-density numbers very often. Those are typically target densities for coastal contracts. Planting densities of 1,200 stems per hectare or less is quite rare in the interior. Trees are much less expensive to plant in the interior than on the coast, so foresters prefer to aim for higher densities to maximize the chance of meeting free-growing survey requirements. In the interior, you're most likely to see target densities of 1,400 stems per hectare and above. Of course, when you're planting a block, the trees are not going to end up in a perfect grid. Nor would you want to try to plant them in a perfect grid, because to get it exactly right would mean having a tape measure and measuring the distance between each tree. That would slow you down and you'd plant less, which means that you'd make less money. The great thing is that your trees don't need to be exactly the same distance apart every time. If some are closer to each other and some are further away from each other, you can still get the right overall density by making sure that, on average, the trees are the proper target distance from each other. So, to make your life easy, think of the target spacing as the optimum average distance between trees that is required for you to hit the correct overall density. You can plant some closer together and some further apart as long as the average is correct. There are 2 benefits to being allowed to vary your distance between trees. The first is a benefit for the trees. Since you have a variance, you can select the best microsites for the trees. The forester wants you to put the trees in the best microsites to maximize the long-term crop yield on the plantation, so it's in his or her best interest to allow you this variance in spacing. The second benefit is for the planter, and it's a very obvious one. If you're allowed some leeway in picking and choosing the spots to put your tree, you can select the easiest spots to plant each tree. You want to find the easy spots to plant in. As much as being successful at tree planting means a lot of hard work, you shouldn't be doing unnecessary work. Of course, there are limits on how much variance you're allowed. That's where the minimum spacing comes into play. You won't be allowed to plant 2 trees closer together than the minimum spacing, or one of them will be faulted. So, for instance, if you have a contract or block where the target spacing is 2.7 meters and the minimum is 2.1 meters, then you'll want to plant your trees about 2.7 meters apart on average, with no 2 trees ever being closer than 2.1 meters together. Many planters at this point will ask an intelligent question. If there's a minimum spacing, is there also a maximum spacing? Well, there isn't, at least not exactly. You might think that there should be, however, there isn't a maximum spacing measurement per se. Instead, there's a different measurement which effectively mimics the effect of having some sort of maximum spacing. It depends on the quality system you're working under, but it usually relates to having a missed spot rather than wide spacing. I'll explain that in more detail in a few minutes. When it comes to density, you need to learn pretty quickly to get it right the first time. Density problems cannot be fixed by replanting unless you pull up every tree from an area and start again, which is unthinkable. It only takes a minute or so for a planter to quickly throw a plot on himself or herself and to count the number of trees in the plot. If you want to be a good planter, or if you already consider yourself to be a good planter, you're only fooling yourself if you think that you don't need to throw plots on yourself. I personally recommend that all planters take at least 4 quick plots on themselves every day. I do it. In the long run, it's worth my while. Many planters find the concept of density to be fairly easy to grasp, but they have much more difficulty with excess. Some planters mistakenly think that the two are the same thing and that high density is the same as excess. However, this is another area where understanding the fine distinction between the two concepts will help a good planter become a great planter. High density and excess are somewhat similar. But high density happens when you have too many trees planted throughout the block consistently. Excess happens when you have too many trees through just some parts of the block, specifically where the plots land. For the mathematicians out there, let me give you a better definition. Excess penalizes you if you have a high standard deviation. The easiest way to explain the difference between excess and density is probably with a very simple mathematical example. First, let me explain how excess is calculated. In most systems, each plot on a block is considered individually. If the plot that you're looking at has more planted trees than the target density, then each extra tree above the target density will be considered to be an excess tree. Once the forester knows how many excess trees there are in total in the series of plots, that number is divided by the total number of trees on the block to come up with the excess percentage. Let's look at an example. First, assume that the target density is 2,000 stems per hectare. This means that if you divide by 200, because a plot is 1/200th of a hectare, you should be hoping to get a total of exactly 10 trees in each plot. Let's assume that we have 2 blocks. Each is 2 hectares, and to keep things simple, we'll say that each block needs 2 plots. Under the FS 704 system, a block that small actually needs a minimum of 5 plots, but we're going to ignore that rule for this example. Just 2 plots per block. On block A, we get 10 trees planted in the first plot and 10 trees planted in the second plot. On block B, we get 8 trees planted in the first plot and 12 trees planted in the second plot. Let's assume that we've been told that 4,000 trees were planted in block A and 4,000 trees were also planted in block B. Although it isn't important in this example, I'm going to tell you that the trees in block A were planted with fairly even spacing, hence the reason that each of the 2 plots got 10 trees, while the spacing on block B was a lot more varied, with some sections having closer or tighter spacing than other parts of the block. For block A, the calculations. The total number of trees in the plots is 20. There are 2 plots, therefore there's an average of 10.0 trees per plot. Multiply this by 200 and you get a plotted density of 2,000 stems per hectare. The total number of excess trees in the plots is 0. The first plot had 10 trees, and you don't get an excess tree until you go 1 tree over the target. Therefore, that plot did not have an excess tree. The second plot was exactly the same, no excess trees. Therefore, the total excess for the block is 0 trees out of 20 trees planted, or 0%. For block B, the calculations. The total number of trees in the plots is 20. There are 2 plots. Therefore, there's an average of 10 trees per plot. Again, multiply this by 200 and you get a plotted density of 2,000 stems per hectare. The first plot had 8 trees, so there are no excess trees in that plot. However, the second plot had 12 trees, which is 2 trees higher than the target number of trees per plot, or 2 excess trees. With no excess in the first plot, and 2 excess trees in the second plot, the total excess for the block is 2 trees. You then divide that number by the total number of trees planted that showed up in plots, which was 20, and you get an excess percentage of 10%. Hopefully this numerical example starts to illustrate the concept. The planted density on each of the 2 blocks is exactly the same because each had 4,000 trees planted over 2 hectares, or 2,000 stems per hectare. The plotted density on each of the 2 blocks is exactly the same because each block had 20 trees in total between the 2 plots, or 10.0 trees per plot, which, when multiplied by 200, gives you 2,000 stems per hectare. By the way, in this particular example, the planted density is exactly equal to the plotted density. Remember that it doesn't always turn out this way, depending on where the plots fall and how many trees are in each plot. In fact, it's most common for these 2 numbers to be different, although they are usually quite close to each other. Even though the plotted density of both blocks is the same, and the planted density is also the same on each block, the excess on each block is not the same. The first block was planted with very consistent spacing and did not end up having any excess trees. The second block had inconsistent spacing and ended up getting a few excess trees in the plots, resulting in an excess percentage of 10%. Under the FS 704 system, a company is not penalized for excess charges on a block if the overall excess percentage is less than 7%. In other words, you can have a small amount of excess and not get penalized for it. This is fair because even the best planters will be forced to deal with a small amount of variety in their spacing. And to be honest, the foresters are okay with a bit of variance in your spacing too, because they want to see you looking for the best spots for the trees.
Earlier, we learned that wide spacing is not necessarily a quality fault. This is especially true if the spacing is consistently just a bit wider than the target spacing. Wide spacing only becomes a problem when it gets to be too extreme. There is a point when your spacing between 2 trees becomes so wide that you could have fit another tree in without it being too close to the other trees. At that point, it's considered to be a missed spot rather than just wide spacing. This is equivalent to a fault on the plot sheet. There's no specific code for this. You still get penalized though, because you don't have enough satisfactorily planted trees to match the number of plantable spots. These are 2 terms that we'll look at later. Basically, let's take a quick example where the target spacing is 2.7 meters and the minimum spacing is 2 meters. To keep things simple, let's work in just 2 dimensions. That is, going in a straight line, although of course on the block you also have to think of trees beside you, not just the ones ahead and behind. Let's assume that as you're planting along in a line, you plant 2 trees that are 3.8 meters apart. This is wider than the target spacing of 2.7 meters, but wide spacing is not a fault. Now let's try to figure out if we have missed a spot. Let's see if we can stick an extra tree between the 2 trees. We'll put it in the exact center of those 2 trees. Since they were 3.8 meters apart, a tree in the exact middle will be 1.9 meters away from each of the 2. That's under the minimum spacing of 2 meters. In other words, it's not possible to legally put another tree between your first two trees without it being closer than you're permitted to be. If you can't legally add that tree, it's not a missed spot. The spacing is just wide spacing, no penalty. Let's look at a second example where you plant two trees that are 4.8 meters apart. That's really quite wide if the target is only 2.7 meters. Once again, let's try to put a tree between the first two. If you put it exactly in the middle, then the new tree is 2.4 meters away from each of the other two. This is above the minimum. In fact, it's pretty close to the proper target spacing. Since another tree can be added in the middle without causing minimum spacing problems, you'll be considered to have a missed spot. There should have been a tree between those other two trees, so you're faulted. Of course, in considering whether or not you have a missed spot, the forester also looks at other factors. Is the spot that was missed good enough to allow for a tree to be planted properly? If not, say for example there was a huge puddle right there, then the forester will not penalize you for missing the spot. The rationale in this example is that you skipped the spot because you had no choice, so you shouldn't be penalized.
So overall, there are 3 different ways that you can be penalized for planting either too many trees or not enough trees in an area: missed spots, excess, and low density. Missed spots come into play when your spacing is wide and erratic, because you'll end up leaving gaps that should have had trees. For a planter, that's not good. If you walk over a spot where you should have planted a tree, you just missed out on an opportunity to make a bit of money. You don't get paid to walk around. Excess comes into play when your spacing is erratic and you put too many trees into a small area that a plot lands in. Now, to be honest, it's usually good for planters to have slightly higher density than the target, and if a little bit of excess is the result, that's usually fine. As long as your crew's excess on the block is under 7%, your company is not penalized. Low density isn't something that I've mentioned yet. I did say that wide spacing wasn't a quality fault. But because foresters want to see a sufficient number of trees on their blocks, they often add a clause to the contract that gives a minimum acceptable density tied to payment. This is usually about 200 stems per hectare under the target density, or 10% under. So, for example, a contract might say that the target density on a block is 1,800 stems per hectare, but if the final density is less than 1,600 stems per hectare, there's no payment. If your crew ends up planting less than 1,600 stems per hectare, there's a simple solution. You'll be sent back to add some more trees until the density is brought up over the minimum. If you have a smart foreman, he or she will probably do a quick calculation as soon as the block is done to see what the planted density is. If it's low, say around 1,600 stems per hectare or slightly lower, that will indicate a possible problem because the plotted density will probably be very similar. If that happened, it would be smart for the foreman to tell the crew to go back out and put a few more trees in as a precautionary measure, perhaps half a box each. It's easier to add more trees to a block when you're already there instead of coming back later. And if your planted density for the block is obviously low, it's smart to fix the problem before the plots are even taken. Is there a high density penalty? Not really. Foresters get you on the excess charge, so they don't worry about having a high density penalty. Many foresters are okay with you planting slightly higher density than the target, as long as it's consistent. They just don't like inconsistent high density, which is why the excess calculation meets their needs as a way of making sure that you don't plant far more trees in an area than you're supposed to. And even density that is perfectly consistent can still give you an excess charge if the density starts to get too high. I'm sure that at this point, many of you are sitting there with your eyes glazed over, completely lost. That's understandable. This is the sort of video that you could revisit a couple times a season for your first couple years until you fully understand the math behind everything. To be honest, what we've just covered here is barely scratching the surface of a proper understanding of spacing and density management considerations. For a first-year planter, though, it's enough to get you started. The key takeaway lesson here is that you need to get your density right, and in order to do that, you need to make sure that your spacing between trees is accurate and consistent. Instead of using a measuring tape to measure between each tree, throwing a plot on yourself is a quick way of seeing if you're on the right track. Even if you don't check the quality of each tree in your plot thoroughly, a quick density check can be thrown in less than a minute, and if you have the right number of trees in your plot, you'll feel more confident in proceeding at full steam ahead. Your instructor and your foreman will throw some plots with you to make sure you completely understand how to take plots quickly and accurately. If you're trying to learn more about the tree planting industry in Canada, then a book called Step by Step, A Tree Planter's Handbook is going to be your #1 source for information. All of the information in these videos came from Step by Step, although the book contains about 3 times as much information as the videos do. Let's take a quick look at what's inside. Why do we plant trees? Health. Working safely and hazards. Vehicles and transportation. Camp life and other lodging. Map reading. Nature and the environment. Basic silviculture knowledge. Stock handling. Common coniferous trees. Prescriptions and planning. Planting equipment. Camping gear and clothing. Planting a seedling. Meeting quality requirements, density and excess. Site preparation. Additional planting techniques. Maximizing productivity. Planting throughout Canada. Applying for a job. Working with helicopters. Coastal planting. Logging and harvesting. Other silviculture work. And there's more. The few hundred pages that you just saw represent only a bit more than a third of the full book. To order a copy today, search for it on Amazon or visit replant.ca/step-by-step.